guys, we are going to do this last very long example of great circle sailing.
west and 50 degrees north, situated on the track we drew.
Same lengthy question like last one. We have to find the
Perfect.
initial,
So
final
let's start by
course,
drawing a
position of
diagram. Now both the
vortex,
latitudes are in
distance
the
of great
9
circle,
hemisphere. So we
and
draw the
where will
pole
the track
towards
cut
another
37
hemisphere.
degree west and
So
15
in
degrees
the southern
north.
hemisphere, we draw the pole towards the southern
So
hemisphere.
we have the position
And
A
if
and
one of the
B,
positions was in the north and the other in
5123
the south,
north,
we normally draw the pole
00936 west,
of
B
the
is
higher
46
latitude.
north, 49
And
west.
latitude
So
which has
we
the
can
higher
see
value,
that
we draw
B
the
is
pole towards that latitude. All
northwest
right.
of A.
So if this is
So we make the
the
diagram,
pole, P is the pole.
and P is
And
the
the pole
pole
in this
because
case here,
A is higher
if
latitude, so we
latitude
use
A
north pole.
is located from the equator at 51
And
degrees and
now we
23
need to
minutes,
find PA.
then
So
PA
A is
distance from the pole to the
5123. So
latitude
PA
will
is
be
90
90 minus
minus 5123
5123,
is equals to
which is equal to 38
3837.
degrees 37 minutes. All right, I know the approximation is not very accurate here, but
So
just
not
bear with the
very
diagram.
accurate,
All right, the
but
second one is again
we
V.
can just
V is about
approximation we
46
can do.
degrees
Then
located from the
PB,
equator.
so
So
90
PB
minus
would be
B
90
is 90
degrees
minus
minus
46 equal
46.
to
The
44
distance between
degrees.
the
So
pole and the
PB is
latitude would
44
be
degrees.
90 minus 46, which is 44 degrees
And
here.
now we need to calculate
Angle P is the D long
angle P, D
between
long.
longitudes A and
That
B.
is
Now in this
difference
case,
between
both the longitudes are in the
936 west
western
and
longitude. So
49
all we
west.
do is
So both west. So
subtract
just
one from the
subtract
other. So
49
the
minus
one longitude is
936. You get
049, the other one is 009 degrees. If you've seen my other videos, you know how to calculate a D long. If they are both on the
39
same
degrees for
side as
24
it is
minutes.
west, then you just
So
subtract.
both are
So
west.
the
So
answer that you should
subtract,
be getting is 039
and
into
less than
24 minutes.
180. So just keep it
And
as it is. And the
the
sign
vessel
will
is
be
proceeding
vessel
on a
is
westerly
proceeding
route from A to B.
from west
Right,
to more west.
something like
So
this.
that is.
This is how the vessel is going. So this is the first part where we draw the diagram correctly and label it correctly, because you need to use these
So it's
values to
very
find
important
the
to draw the diagram
rest of the
correctly and
values. So
labeling
we'll start
and
with
giving the names
finding out
correctly.
the great circle distance
Now we
AB
need to
first.
find the great circle distance. So you
To
know the
do that,
cosine
we'll go
formula.
back to the spherical
Cos P is equals
trigonometry
to cos AB
principles, where
minus
if
cos
you have
PB
an
minus
included
cos
angle, which
PA
is
upon
angle
sin
A in
PB
this
sin
case,
PA.
and if the sides
Or
next to
cos
it,
of the great circle
such
distance
as
AB is
PA
equals
and
to
PB,
cos
if you
P,
know the
and
three
sine of
values, you can find out the values of the
adjacent
rest of
side
the
PA
triangle
PB
as
and
well.
cos of
So
adjacent
that's how
side
you write
cos
down the
PB cos
formula. You
PA.
write down cos P,
So
which is the included angle,
we put all
and
the
side
values
opposite to it, which is cos AB,
and we get AB.
minus cos AB as
So AB
26.22 degrees as calculated.
you got 26.22 degrees, and
To
to get the
calculate the
distance we
initial
multiply
force
by
from
60,
A, initial
1573.5
force is
nautical
the
miles.
angle A in the
But in
diagram.
other
So you
parts
can
we
see
are
the included
using
angle
always the
A, and
degrees.
this is the initial
So
force.
now
The
to
vessel is on
find the
the initial
initial
course A.
course,
This
cos
can be, in
A,
this case, it looks like a
we,
southwesterly
it
course
here
if
it
it was
looks
straight
like a
lines. But these are curved lines. These are
southwesterly
great
course.
circle courses. They are drawn
These
as
are great
curves on the
circle
mnemonic
courses,
charts. So it
and
could be a
it
northwest
could be
component
a
as
northwest
well.
or
So it
southwest.
can either be in the
So let's
northwest
see, after
or it could be in the
calculation we will come
southwest.
to know if
Now,
it
how
is
do we
more than
solve that? If it
90,
is less than 90, that
then
means
it
it's
is
still in the
southwest, and
northwest
if it is less
quadrant.
than 90 it is
If it
northwest.
is more than 90, that means the vessel is on a
So
southwest
let's
quadrant.
calculate initial course or angle
Alright, so
A.
let's start here. So
So if we
initial
put the
course
formula, cos
is
A is equals to
cos
cos PB
PB,
minus cos AB
which is
minus
cos
cos
A is the
PA
initial course,
upon
is
sin AB
the
sin
included
PA.
angle. Then you write the side opposite to it, which is
So
PB,
cos of
and the remaining two
angle is
sides, and the
equals
cos of
to
the
cos
remaining
of
two sides,
opposite
and the
side
sine of the remaining two sides in the
minus cos of
denominator.
adjacent side upon
That's
sine
how
of
you get your
adjacent sides.
initial course.
So
Simply
we
put in
get
the values this time,
angle A as 86.2
and
degrees, and we round
match
it
the
up
values given by
to
me in the calculation
nearest
here.
degrees.
They
So
should match.
86 degrees. So
If
north
they don't, check your
86
values
west
again.
is
I've
our
stuck to
course,
5 decimal places
and
because
it is
that's how
northwest. So we
popularly it
convert
is done.
to
You can go up to more, it
uh,
will give you more accuracy, but 5
360
decimal
degree
places is good
cardinal.
enough. 2 would be too
So
less, but 4 to 5 decimal
274
places is
degrees true
usually
is
more
our
accuracy.
initial course. So
So this
remember
gives
to
you the
always change in the
initial course
cardinal
as
direction.
86.2 degrees.
Then we need to
But
find the final
courses
course
cannot
B.
be in
So we put
decimals
in the
because you
formula
can't
cos
steer
B is equals to
decimal
cos of
places. Courses
opposite
have to be in
side, that
round
is
figures.
PA,
That's why
minus
I've
cos of
rounded it off
adjacent
to
side
3
upon
decimal
sine of
places.
adjacent side. So cos PB cos
Because it
AB
is
upon
less
sine
than
PB
90,
sine
that
AB.
means
So
if the vessel, if this calculator,
So we
We should
got
ideally
B,
given B
angle
as
B as
63.7 degrees
63.7
this way,
degrees. So we
but we
rounded
round it
up
out to
to
64
nearest
degrees
degree as
also because
64
the decimal
degrees.
place is more than zero point
So
0.5.
final course is
Your
angle
B is
B,
64 degrees. Now if I go
but
back to
we
the
need
diagram
to
here,
see the
your B is
course of the
64,
ship.
that
So
means
we
your
got angle
internal
B
angle B is 64 degrees.
64 degrees,
Just take
and
your
course
internal
of
angle
the
B is
ship is
86
in
degrees.
other direction. So we need
But what I
180
need is the
minus
final course here,
this,
and the final
because
course
180
will be
minus the
something like this here. The vessel will be on a
straight
course
line
here,
and measuring from
right?
the north
So you
pole,
need to find out
and
the
then subtracting
external
from
angle BD.
360. So we
Now
need
if I
the
draw
angle
another
from
diagram
north
here,
pole.
it might make your understanding easier.
So
All right. So my
180 minus
vessel
64 is 116, and that is south
is transiting
64 west.
northwest
So we
here.
subtract
This
from
is V here.
360.
You need to find out the outer angle to find the course as measured from the pole.
So we need
So
to
what you do is
find
subtract it from 180 because each quadrant is 180 degrees, right?
either we
Each
can give
quadrant is
from south
180. This is
pole or we can
not
give
each quadrant, but the
from
sum of
north
all
pole.
quadrants is 180. All right. So
So you
this
can
is the northwest
write
quadrant. So subtract it from
south
180.
64 west
What
or
you find
180
here is
plus 60.
64. Subtract it
So
from 180 to get the
244
outer angle
degrees.
here.
0
What you
244
get is
degrees true
116
will be
degrees.
our
When you get
final course.
116 degrees, this basically means
Now
that
to
your
solve
vessel is
the
on a
vortex,
course of more than 90, which
so
means it
our
has moved out of the northwest
courses are
quadrant
in
now and
different
gone into
quadrants. You can see
southwesterly quadrant. Alright, so 90 degrees, each
B
quadrant
is
is
in
90 degrees.
southwesterly quadrant and A
If
is
you
in
are on a course of
northwesterly quadrant.
116, which means you have overshot the northwest quadrant by 20.
So now to
Initial and final course
calculate the vortex
when in
between
different
A and
quadrants,
B. So we have different quadrants. So
your
vortex will
vertex
lie
will lie between
between
position A and B.
the A and B points,
So in
and
this
vortex
case,
is
your
always
initial
90
course
degrees
was in
and
the
the
northwest
maximum
quadrant,
latitude.
as understood above, and your
So
final course is
initial
in the
course was northwest, final course was
southwest
southwest.
quadrant, as
So
we
our
found out before.
vortex is in
So because they are in
initial
different
and final
quadrants, the
course
rule
in
of
different
thumb is
quadrants.
that
So
the vortex
vortex is
lies
in between A
between
and B.
A
So
and
we
B
draw the diagram,
and always lies
and
towards the
vortex we
highlighted area.
always use Napier's
If
rules.
both the courses were
So
in the same quadrant,
in
vortex
we
would lie
take
outside A and B
triangle
towards the highlighted
PAV.
area.
You can use
Right,
PBV
something
also.
like this probably.
So in
Okay, I'm going to delete
PAV,
that now
uh,
because you don't want that right now, otherwise it will cause you confusion. Right.
vortex
So vertex
is
lies
equals to
somewhere
90
between
degrees.
A
So we make the
and B.
circle,
And
and
to find
then
out the vertex, we use the principles of
adjacent
Napier's rules
sides
because it is
AV
a
and PV,
right angle
then
triangle.
opposite angles 90
Where
minus
angle
A,
B
90
is 90
minus B,
degrees.
and opposite
Now to
side
use
90 minus PA.
Napier's rules, we just take any one triangle. I am taking triangle
So
APV.
let's see
You can
what
take
all
triangle
we know.
PBV if you want,
So we know
but I am
PA
taking triangle
and we know
APV,
angle A.
right? Which is this triangle here.
So we know the two things. So we
Here
can
vertex
find
is
out
90
what we
degrees.
need to find out is longitude and
We write
latitude
down
of
AV, which is the side
V,
next
that
to the
is
vertex
PV,
angle, and
and
PV.
angle P.
It can go in any order. Then the angles opposite,
So PV
and then I can
will
find out
give
the
the
latitude of the
latitude of
vortex.
vortex.
So I will use a rule:
90 minus
cos
PV
of the
is
middle equals, so
latitude
the
of
sine
V,
of the middle equals cos
and
of the
P is
opposites
the
here.
longitude. So sine
So
of
sine of the middle as
PV
PV,
is equals to cos of
and
opposites,
cos of the
90
opposites
minus A,
as
90
cos
minus
90
PA.
minus A and cos
So
90
sine PV
minus
is equal to
PA.
sine A, sine PA.
Cos
So
90
we
minus
get
A is also
PV
equal to sine
is
A, or cos 90 minus
38.5
PA is also
degrees
equal to sine PA.
or 38 degrees,
Alright, since we need to find
30.9
out PV,
minutes
just follow my
if you
prompts here as I have
do
shown
from
here in the
calculator. So
calculation.
latitude of vortex is 90
Put in the
minus PV.
values.
So 51
What you should be
degrees,
getting is PV equals to
29.1
38
minutes
degrees
is the latitude
30.9
of the
minutes.
vortex.
Now remember,
Now to find
PV
the
is the
longitude.
distance from the pole to the vertex. That's not the latitude. To these three values.
So to
So
find
we
angle
put
P,
PA
we
into
again
V and
use
then tan
A
of
and
adjacents.
PA
This becomes
because
Napier's rules,
always
right?
use the values which are given before. Because if you
So
are
sine
using the
90 minus
values
PA then
which you found,
becomes
if there is an
tan
error,
90
then
minus A
you will get more error
multiplied by
in the
tan
next
90 minus
answer.
P.
So sine 90 minus
We
PA
need
is
to
equals to
find
tan
angle
of
P.
adjacent
So we
sides.
need to do a
So
little of
tan of 90
adjustments
minus
with
A,
the
tan 90
equation.
minus P.
Your known stays
We
on the
sine
one
90
side,
minus P is equal to
the
cos PA.
unknown goes on to the other.
So we put all the values and we need to
Put in the
find
values here as I have. Follow my prompts given here.
we need to
What you should find out is P
get
will be equal to
angle P. So tan angle
4
P,
degrees
tan 90 minus P
and
you put on one
51.5
side,
minutes.
and then we get angle P as 4 degrees,
Now why I have named it
51.5.
west is if I go back to the
Now
diagram
why
here,
we make
you
it
can see
west?
that
If
A
we
is
can
in the
see
west
that
longitude.
V is on the west
Let's
of A.
let's go back to the first diagram, then it will be clearer because I have written all the
And you
values
can
of the
see in the
longitude
other
there.
diagram
So
also,
A is in
A is
00936 degrees,
00936 west,
B is
B is
049 degrees, but
049
vessel is
west.
going
So vessel is
further
going more
west.
westwards,
So
and
the
vortex is in
vortex
between
is
them.
located further west
So
of A.
vortex is also
Alright,
west of
so if
A.
I go back
So that's
here,
why we have written
you can see the vortex is located
vertex
further
is on the
west from A.
west. That's why I've
So the
written
west longitude
west.
has to be increasing,
So longitude has to be
and
increasing.
that's why
So 4
D
degrees,
long will be
51.5
west here in
west.
UP.
So
So you
longitude
have
of A
longitude
is
of A
0,
as a
zero
reference,
nine
and you have
36
D
west.
long or
D
angle
long is
P
04
that you just calculated.
51.5 west. So
To
longitude of
find out
B
the
is
longitude of the
014
vortex, we'll
27.5 west.
add to the
So
west
we got the
longitude
longitude
because
and
you are
latitude
going
of the
further west.
vortex. Now
So
we
the
need
answer you
to
should be getting
find
is
the
014
other
degrees
latitude and
27.5
longitude of the
minutes.
intermediate point. Where does the track cut the longitude
Let's
of
move.
37 degrees west? So we need to find
Continuing
the
on this
latitude of
longer question,
37 west, that is point
if on the
M.
same
So
question I
we'll
ask you
take the
where does the
triangle
track cut the
PVM, we
longitude of
put in the
077
Napier's
degrees
rules,
west,
and the
you know that
center
037
is
degrees west
vortex
would be
90
somewhere
degrees,
west of the
and
vortex. So
we
if
have
the vortex was
PV we already know.
014 degrees
VM we
27.5,
need to,
you know
uh,
that,
we
let's
don't
spot
know.
the point M.
We
It
know
will be cutting
angle
somewhere here.
P, that is our
This
D long, our
37 degrees
longitude is
west would be
given,
west of
and PM we need to
the
find out, that is our
vortex.
latitude.
Now what we do is then we need to find out the then
So
P
putting these
becomes
three
the
in one equations,
midpoint.
so
And
midpoint is
tan of
sine
adjacents is the rule that we
90
use
minus
for
P
Napier's
equal to
rules.
tan
So
of
that's what I've
adjacent
done here.
sides. So sine
Sine
90
90
minus
minus
P is
P
equals to tan PV, and tan 90 minus PM.
will be tan
So tan 90 minus
PV
P is cos
multiplied by
P.
tan 90 minus
We
P.
need to find PM, so we put on the other
Alright,
side.
then just
So
use the
PM is equals to
terms that I
40
have given
degrees,
here. We need to
45.1.
find
That is
PM, so
our
that's why I've transposed the
PM
equation,
side.
keeping my
So we
known to the
need
one side and
to
taking the
find the
unknown to the other
latitude of
side.
M. The latitude of M
Putting the
is
values
90
here,
minus 40, 45.1 is
keep
equal
going.
to 49 degrees,
See the
14.9 north.
points that I've given in the question here,
So
the answer that I've
that's,
given.
we got the answer for
Match these
M, where
answers,
it cuts the circle, or latitude of
recheck
M.
them.
Then we need
So what
to
you should be getting
find
is
where does the
PM
track cut the latitude,
is
50
40
degrees
degrees and
north.
45.1
So
minute.
50 degrees
So
north
this
will
is
be
PM.
cutting.
This is the
We'll find
distance
out again by this
from the pole
Napier's rules.
to the point M,
Just
where the
make the diagram.
corresponding E in the
So
study
we
group,
make this
because this P would give me the
point
D
N
long between
50
M
degrees
and P,
north,
which I
and we
can then
need to
apply to the
find the
longitude of the
longitude,
vortex,
angle
which is
P.
known to me,
So
and get the
Pn,
longitude of
we know
M.
90 minus 50 is 40
So in this
degrees.
case, PV is 38 degrees
Vortex, we
30.9,
make
as
the
I
Napier's
calculated
rules
before.
circle or mushroom.
PN is 40
PV and
degrees,
Vn
as I've
are
explained
the
before. All I need to
adjacent
do is
sides,
find out
and then
P,
90 minus P, 90
input
minus
these
N.
three in the
So we
same
know
equation,
PV,
two knowns and
we
one
need to
unknown.
find Pn, and we know
Transpose
angle
it
P.
here, we use tan of adjacents. Sine 90 minus
Angle
P,
P we
also
need to
equal to
find out,
cos P.
and Pn and PV we know. So sine of
Putting
middle
the
is equals
values
to
here,
tan of adjacent again,
what you should be getting P
and
is
we
as 18
get
degrees
P as 18
28.4
degrees
minutes. And this
28.4
P
minutes
that I've
west.
explained before gives you the
Now
D long
P is the D long,
between
and we
the
need to
vortex
calculate the longitude
and
of N.
point N.
So from vertex, longitude of
As
V
you
is
see in the
14
diagram,
degrees 27.5 west,
N is also
and N
west
is
of the
also
vortex,
westerly
and
of
as
the
we are
vortex.
going
From
on
the
a
diagram we
westerly
can
route,
see.
the vortex
So
longitude,
we got
from the vortex
this
longitude
18 degrees
westerly, the west longitude
28.4
should be
west.
increasing,
So
right?
14
So we
degrees
have longitude of
27
the
west
vortex
and
as
18 degrees 28 west. So add,
0.1427.5.
and we get
Point
32
M
degrees
is west of
55.9
the
west. That is
vortex.
the longitude of N. So here
So
we
we
complete the
add
full
to this
question. We found out the
to
longitude
find out the
and all
longitude of
the
N,
tracks of M and N, vortex,
which is
latitude,
32 degrees
longitude, initial, final
55.9
course, and
minutes,
the distance.
right?